Hello, my name is Axel Fay. I'm here presenting AxeOS, Axel's operating system, for the CSCI E92 operating systems course at Harvard Extension for using the K70 ARM processor. My operating system contains an in-memory file system, device-independent I/O, which is easy to add to, and some minor shell features. I also did not get a chance to do the final project as of yet, but I was hoping to do so within the week that follows. My memory system is using the ARM processor's SDRAM, the first allocation of which is going to the LCD display. I implemented 3 commands to manipulate memory: my malloc, my free, and my realloc. I implemented my realloc to dynamically allocate memory for files to increase their sizes and add more to a text file, for example. New devices are easy to add to my operating system. Streams are opened per process and then freed when a process terminates. I also use a union to distinguish between a device and a file, so I can use the same structs and the same commands to manipulate them. My file system is completely separate from any processes. That way I do not need to have it dependent on what process is running. I've implemented several different devices from the K70 into the operating system. Some devices are opened more than once so that they can have different context. The UART, for example, is opened 3 separate times for every process to create standard in, standard out, and standard error. The push button is also opened twice, once as a switch and once as a button. My operating system currently has 4 interrupts: the supervisor call at priority 15, my quantum interrupt, which is the SVC call, a serial interrupt that interrupts every time the serial key span takes input, and the PDB0, which is used to flash an LED. I unfortunately did not implement the flex timer yet due to time constraints and the fact that my KDS had the date and time working without it. I also wanted to give a moment to talk about my proposed final project. I had hoped to make a windowing system in my LCD display that could perhaps show multiple processes running at the same time, and perhaps a taskbar like is shown at the bottom of the screen, which would hold the processes that are currently running and would be able to be toggled through. The last part would have been a text editor that would edit any open file and the ability to open multiple shells as different processes. So this is an example of my shell. I'm going to be displaying the help command, and now that I can actually have options for my commands, such as help descriptive. This gives you a better idea of what each command does. Next I'll be displaying the file system. As you can see, I have an ls command that can display them all. The only device that actually has device as a prefix is UART, because I was originally intending on doing a nested folder system. Here I'm giving a display of the malloc and free in the shell, but first I'm going to display how it actually appears in the memory map. This is my memory map, and I'm going to be allocating 120,000 bytes, and you can see it down there, the last location. And now I'm going to be freeing that location defined by there. And you will see that now it's actually completely gone, and it's been merged with the bigger block. I also would like to point to some of the special features that I've added for the shell. For example, I can go forward and backwards using the back and forward arrow, and I have a command history, so I can go through all of my history. I also implemented the backspace, which has been incredibly useful while testing my operating system. Here's my K70, where I have opened the output to the LCD through my shell. I will also take the opportunity now to show the interrupt, the serial interrupt in action, because the scrolling of the LCD is quite slow, so I can show it there. See, I have typed several different commands, and it only pastes them right after it actually finishes execution of the other program, meaning that it's interrupting every time that I hit a key. I would also like to demonstrate some of the errors, because I was very careful in integrating a lot of the errors into the shell. For example, if I type a nonsense command, it will actually display what command that it read, because I have a special location in memory for a error message, right, which I can paste from there. I also have different errors, such as the typical arguments. I will now be displaying the multitask command in action. You'll see a blinking LED at the top, and at the same time I can type to the UART on the same line. And I will be able to push this button and create a message. So that's the multiprocessing in action, and it will execute, it will terminate perfectly as well, and continue on the shell.